Hello viewers, we are going to look at center of gravity, and under center of gravity we are going to consider circular cone and hemisphere, how to find the center of gravity in these shapes. These are solid shapes, 3D shapes, and so we are going to find the center of gravity for these shapes. Now, the question is: a body consists of a right circular solid cone of height 40 millimeter. Means this is the cone and the height is given to be 40 millimeter, and radius placed on the solid hemisphere or radius. Okay, the radius of the cone is 30 millimeter. Has been indicated here. From here to here is 30 millimeter, and the radius of the hemisphere too is 30 millimeter. It has been indicated here. So we are asked to find the position of center of gravity of this body. Center of gravity of this body. So this is a cone, and this is hemisphere. This is not a triangle, because if this were to be okay, let me say this is not a semicircle. It's not a semicircle. This is hemisphere and this is a cone. So we divide it into two. This is the first one being the hemisphere, so we indicate it using 1, and the second shape being the cone. Now, since we are dealing with solid shapes, they are not plane shapes. These are not plane shapes. So when we are dealing with solid shapes, which are not plane shapes, and we want to find the center of gravity, we make use of volume. Unlike in plane shapes like rectangle and the rest, in which we make use of area. But this is a solid shape, a 3D shape, so we use volume. So the volume for hemisphere is 2 over 3 pi r cube. And so we bring in the values into the question, the formula rather. So we have 2 times pi is 3.142. The radius of the hemisphere is given to be 30, and then we raise it to the power of 3, and then we divide by this 3. And so when we do that mathematics, we are going to have this value: 556,556 millimeter cube. Because it's volume, we keep the unit in cube. And then we have to determine the centroid. Okay, I didn't mention this. If you look at the shape is symmetrical about the y-axis. Is symmetrical about y-axis. What this implies is, if you cut this shape into 2, you are going to have the same shape. The half of this and the half of this will be the same. But if you cut it into these 2 halves, up and down, you're not going to have the shape that you have up will be different from the shape downwards. So you cannot say it is symmetrical about x-axis. So it is symmetrical about y-axis, because if you cut it into 2, you are going to have the same shape. And so for the y, we use this formula. We have r minus 3r all over 8. And then in order to find this is the same thing as saying, since we have y1, okay, let me use this, equal to r minus 3r all over 8. So in order to find this, we have, if we take the LCM, take the reciprocal for this one, so we have 8 into 1 into 8 will be 8. 8 times r will give us 8r minus 8 into 8, 1, multiplied by 3r, this will give us 3r. So when you say this minus this, it will give you 5r divided by 8. So that was how we got this 5r divided by 8. And then when we bring in the value of the radius, multiply this by this divided by this, our answer is going to be 18.75 millimeters. So we are done with the hemisphere, which is this shape 1. So we now consider the cone, shape 2. So for the cone, we have that since it is 2, we indicate it using V. Like I said, these are solid shapes, they are not plane shapes, so we use volume while calculating their centroid. So this is V2, The volume of a cone is 1 over 3 pi r square h. That's the volume for calculating a cone. So we bring in the values. Our pi is 3.142. The radius was given to be 30. We raised it to power 2. And the height was this. And so when you do this mathematics, you are going to have 37,704 millimeter cube, because we are dealing with volume. And then to determine the y using the cone, like I said in my other videos, when you want to determine the centroid at this point, I always take my reference from the bottom. Now this is this hemisphere is on top of the cone, is on top of the hemisphere. So if you are taking your centroid, because these two are joined together, and you are moving from the bottom, you are moving from this time, you are moving from the bottom. So you take from here, what's happening to my markers? Moving from the bottom. So from here to this point is 30 millimeters. So you are going to take it 30 millimeters. Okay? But from here down here is 40, which is the actual cone you are looking at. From here to here is 40. But we know that the y for cone is h over 4. The height over 4, the depth over 4. So that's why we are dividing this 40 by 4. But then first you have to take this one, because this also is joined to this one. So we have 30 plus 10. That is, when you say this one, this will give us 10. So 30 plus 10 will give us 40 millimeters. So we've been able to determine the volume and the centroid for the hemisphere. And then for the cone, we can now bring it together to find the centroid, to determine the distance between the center of gravity of the body and bottom of the hemisphere. So we use this formula. The centroid, the center of gravity, will be V1 y1 plus V2 y2 divided by V1 plus V2. We have our V1 to be this, and then our y1 is this, so you multiply, and then you have this answer. And then our V2, this is our V2, the value of our V2, and then our y2, this is the value we multiplied. Then you have this answer. When you add V1 plus V2, that is this value, plus this, you're going to have this answer. When you divide this by this, you have your 27.25 millimeter. So basically, this is how to determine the center of gravity for a circular cone on top of a hemisphere. It's very simple. Remember, when you are looking at solid shapes of this nature, you calculate for the volume, and when you are looking at plane shapes, you use area. Thank you.